Hi, chemistry students. This is your lesson on finding the percent composition by mass of elements in a compound. Please be sure you're taking notes as we go through this lesson. So in order to do this calculation, you have to remind yourself how to find or what the molar mass of a compound is. The molar mass of a compound is the mass of 1 mole of its molecules, and the molar mass is the sum of the individual atomic masses of each atom in the compound. Now you find the atomic masses for elements on the periodic table, so you'll be using the periodic table to look up the mass of each of the elements. So we're going to do an example. We're going to find the molar mass of iron 3 oxide, which is Fe2O3. The first thing you're going to want to do is you're going to want to see what elements are in this compound. Well, you have iron and you have oxygen, but you have 2 iron atoms and 3 oxygen atoms. So, or ions, in this case, 2 iron ions and 3 oxygen ions, but you're going to want to look up the mass of the iron and the oxygen and then multiply in order to get the mass of the whole. So if I look up on the periodic table the atomic mass of iron and the atomic mass of oxygen, what I find is that the atomic mass of iron is rounded to the hundredths place, 55.85, and the atomic mass of oxygen rounded to the hundredths place is 16.0. So we're going to multiply, since there are 2 irons, we're going to do 2 times 55.85. Since there are 3 oxygens in this formula, 3 times 16.0, we add them together. The molar mass of iron 3 oxide is 159.70 grams when you add those together. So a mole of Fe2O3 would actually weigh 159.70, and you should know iron 3 oxide is just rust. So if I have 159.70 grams of rust, then I have a mole of rust. All right, now let's do the actual calculation. How do you find the percent mass of different elements in that compound? So the percent composition by mass of a compound is determined by the ratio of the element's mass to the compound's mass. So here's the equation you will be using. Percent by mass of an element in the compound is the mass of the element in the compound divided by the molar mass of the compound times 100. All right, so we're going to do some chemical analysis problems, okay? I'll move myself here. So here's our first chemical analysis problem. Again, as I told you, iron 3 oxide is just rust. So we're going to find the percentage of iron, the mass of iron that is in iron 3 oxide. What percentage of rust is actually iron? And we're going to apply this equation. Okay. All right. So to find the percent of iron and oxygen in iron 3 oxide, we're just going to do iron. We're going to do the following. The percent mass of the iron would be the mass of the iron in the compound over the mass of Fe2O3, or the molar mass of Fe2O3. So we're just going to take the part that is iron from that initial calculation and divide it by the whole, and then multiply by 100. So if we do that, the iron, we have 2 irons, so the mass of iron is 2 times 55.85, and as we calculated before, the molar mass is 159.70. So we're just going to do this calculation, multiply by 100, and we will find the percentage of rust that is actually due to iron, the percentage of the mass of rust that is actually due to the iron ions. If we do that, we find it is 69.94% by weight iron. So the percent composition of iron in iron oxide would be 69.94%. Now, if we were going to do the oxygen, since there are only 2 elements in here, we would just need to subtract this from 100, and that portion would be from oxygen. But almost 70% of rust is iron, and that's what we have found from this calculation. Now, how can we use this? Well, what you may not know is that iron 3 oxide, the iron can be reclaimed using a blast furnace. So I don't know how many people scrape rust off and try to make it back into iron, but theoretically it's possible, and there are other sources of iron 3 oxide that we use to actually make iron. We do it in a blast furnace, and you can see, if you're familiar with some terms of reduction, which is the gain of electrons, you can see it goes through a process by which the iron oxide is actually reduced. The iron ion becomes liquid iron. A 3+ ion becomes a neutral atom. So it is gaining electrons to do that. It's a reduction reaction within this blast furnace that allows us to reclaim iron from essentially rust, from iron 3 oxide. All right, so let's do a chemical analysis process. Suppose you were given 7.8 grams of iron 3 oxide of rust, and they want to say, let's see if we can reclaim. How much iron could you reclaim, could you recover from that 7.8 grams of iron 3 oxide? Now, how would you do this? Well, how much could you promise? Remember what we just calculated. We know that any amount of rust is about 70%. 69.94% of it is due to iron. So that's probably what we could recover. So let's go back to our last answer. We found out that if 69.94% of rust is due, or iron 3 oxide is due to iron, then 69.94% of any sample of iron 3 oxide, of any sample of rust, is going to be due to the iron. So how do we figure out 69% or 69.94% of anything? Well, remember, the decimal form of 69.94 is just 0.6994. So you just multiply, okay? Out of that 7.8 grams of rust, how much iron could I promise to somebody that I could recover? Well, I can recover 69% from the 7.8. So if you just do 7.8 times 0.6994, you'll get 5.455. If we round to two significant figures, since this has two significant figures, it's 5.5 grams of iron. So I could say, well, hey, I've got this much rust, I've got this much iron 3 oxide, I could recover, theoretically, 5.5 grams of iron. See, you're a chemical engineer. All right. Now, of course, this means that of the sample, 2.3 is due to the oxygen. Okay. So you can always figure out one from the other, especially if they're just two elements. Okay. Let's have you do another chemical analysis problem. Go ahead and stop the video. And I want you to find the percent by mass of hydrogen in H2O. So follow the same steps, use the same chemical formula, let's go back to the formula itself that hopefully you have down here. So you're going to put the mass of hydrogen over the molar mass of water. So you're going to have to figure out the molar mass of water. You're going to have to figure out how much of that is due to hydrogen. And so you may want to pause the video. And if you do it correctly, you should get an answer of about 11.2%. And that is your lesson on finding percent mass of an element in a compound. You have an exit ticket on Canvas where you're going to do another calculation that you will upload. So make sure you go to Canvas and finish this assignment and do the problem on Canvas and show us that you understand this process.